In 6.3, we started looking at sine and cosine as functions, and of course, functions have graphs. So our goal today is to get familiar with the graphs of sine and cosine, and also some of the transformations of sine and cosine. And theoretically, you remember transformations from Pre-Calc 1 from Math 141. But if not, I will try to remind you of the basics that we need. Okay, so you know from your unit circle that if we're talking about sine, that we're talking about the y-coordinate on the unit circle. And I could say things like sine of 0 is 0, and sine of pi over 6 is 1/2, and sine of pi over 4 is square root of 2 over 2. And I could keep going like that, and we could make a table. So I'd say if t is 0, that sine is 0, and if t is pi over 6, then sine is 1/2, and you can keep going. You can make a big table. And of course, the point for us for that table really is to then turn that into a graph. So if you have a t-axis and a sine of t, or y-axis, you can start plotting these points. And so you have a point at 0, 0, you move over to pi over 6 and have a point at 1/2, and keep moving over and keep plotting more of these points, and we get eventually get a graph. So here we're at 2 pi by the time we get here, and this is at 0. We get a graph, and you get the basic idea of the shape of a sine function. And if you have an older TI calculator, you've even got this shape on the cover of your calculator. But that might be a familiar shape to you. So that's the basic idea for a graph of sine. And we could certainly do the same thing with cosine. I won't make you do a bunch of points, but cosine has a similar sort of an idea. We know that cosine of 0 is 1. So cosine starts up here and goes about like that. And both of these we're looking at, so this is 0 to 2 pi. Both these we're looking at one period here, right? This is a space of one period. And after that, they'll start repeating themselves. They do keep going. So those graphs are graphs that you should more or less have memorized and be able to replicate at any point. And of course, what we're going to want to look at doing now is looking at transformations of those functions. So if we start with a graph of basic sine, zero to 2 pi, and this is 1, this is -1, 2 pi. We're interested in things like what happens when you multiply the function on the outside. Sorry, I should have been using t here. When you multiply the function on the outside by, say, 2. And if you remember from Pre-Calc 1, that says that affects the y values. It just multiplies all the y values by 2. The x values don't change. But any y value gets twice as big as it was before, so the function goes twice as high. 0 times 2 is still 0, so that point's the same, and goes twice as low. It goes up to a height of 2 and down to a height of -2. So we've got one transformation there that's called a vertical stretch. And in trig, we have a special name for that kind of transformation. which is amplitude. Amplitude just refers to the distance from the middle of the sine wave to the top of the sine wave. So let's see, let's get a different color here. That distance right there is the amplitude, which happens to be 2 for this function. Okay. Also wanted to remind you what happens to the function if you multiply by 2 on the inside of the function. So let's start with basic sine again. Going from 0 to 2 pi, that's y equals sine of t. And let's look at what happens with y equals sine of 2t. So this time we're multiplying the 2 directly to the input, so it messes with the side to side, the x, except now it's t. And you might also remember that what happens inside the parentheses sort of has the opposite, I call it opposite land, has the opposite effect of what you'd expect. So it really says multiply the t values by 2, but really what that means is the t values have to be half as big to produce the same y values. So it has the effect of compressing this spring in. And rather than taking 0 to 2 pi to do a complete cycle, it does a complete cycle in the space of 0 to pi. And of course, since it keeps going, I guess you'd get another complete cycle. So you actually get 2 full periods in the space of what you used to get, 1 full period. So that's before we had an amplitude change. Now we have a period change. So this really brings us down to 2 basic ideas here. So we've got, compared to regular sine of x, we've got possibility of having a number in front of the sine function, which the book tends to call capital A. And we've also got the possibility of having a number in front of the t, which the book tends to call, this looks like a W, it's actually a lowercase omega, Greek letter. It doesn't matter what you call it, but there can be a number here and a number here. And I'd like to point out that that number right there controls the amplitude. So if that's a 3, the amplitude will be 3. If that's a 10, the amplitude will be 10. And this number right here changes the period. But unlike amplitude, the period is not, if this number is 2, the period's not just 2. Keep in mind, up here, we had a 2 there, and the period actually ended up being pi. So it was the original period, 2 pi, divided by this number, divided by 2. So in general, down here, we're going to have the period, and the period will be 2 pi divided by omega. And the last bit of transformation that I wanted to point out was we can also just shift the whole function up or down, a vertical shift. And that, you might remember too, is just a plus k on the end. So we've got a vertical shift. Okay, so those are the 3 transformations we're going to look at for sine. Could do the same thing for cosine, of course. Let's just start with the basic cosine shape and change it. So we'll look at some examples in the next video.